All right, let's go ahead and talk about thermochemical reactions. And so a balanced chemical equation, if we think about a balanced chemical equation that we've learned throughout the year, one component that we have not learned about it is whether or not that reaction absorbs energy to occur or if it releases energy. And so what we're going to do is we're going to take balanced chemical equations that we already know, that we've already learned how to write and balance and all that, and we're going to add the energy component to it. And so a balanced chemical equation that includes the physical state and the quantity of energy released or absorbed is called the thermochemical equation. And so essentially the thermochemical equation is a chemical equation, but it just includes the energy. Now, here's a couple examples of thermochemical equations. Notice how it looks just like a regular balanced chemical equation, except for notice the first one adds energy in the products, and the second one has energy as a reactant. And so if you have the energy in the product side, that means energy is being produced. That means it's being given off. That means if you were to feel it, it would probably feel hot because it's giving off energy. Now the second one has energy in the reactants, which means that it requires energy to occur, which means it's absorbing energy, which it's absorbing that energy from its surroundings, and so it's absorbing energy for it to go to the product side. So now that energy change, all right, so the energy change that is given off or absorbed, we call that enthalpy. All right, and so the enthalpy of a reaction, which is the change in energy, which we call delta H. Again, the delta means change, and then H stands for enthalpy, is the amount of energy released or absorbed as heat during a chemical reaction. And so, again, enthalpy is the amount of heat released or absorbed in a chemical reaction, and enthalpy is represented by the letter H. Now, enthalpy, which is H, is the name given to the heat content of a system, which is your reaction that occurs at constant pressure. And we can't actually measure the actual enthalpy of a substance, but you can measure the change in enthalpy. And so every substance has a certain amount of energy associated with it. And what we really focus on is we don't focus on how much energy does a substance have. We focus how much energy what is the change in energy when we go from reactants to products. In other words, how much energy is released or absorbed. Now, this amount of heat energy absorbed or lost is again known as enthalpy. And for this class, what we're going to assume is that enthalpy is the same as Q. And so we learned about Q equals MC delta T. And so we're going to say that enthalpy of a reaction is also going to be Q. And so you'll learn in AP Chem, in future chemistry courses, or whatever courses that it's not quite the same, but we're going to assume that it is the same. Now, thermochemical equations are often written by putting a sign in front of it rather than writing it as a reactant or a product. And so here's an example of what I'm talking about. And so if you take a look at the top equation there, the first equation at the top there, you'll see that the delta H is the energy change is in the product. And so that is the thermochemical equation, but you can also take that and write it separate from the equation, where you say that the equation itself has a delta H of negative 891. Now, why is it a negative 891? Well, it's a negative 891 because it's giving off energy. So when this reaction occurs, it loses that energy. That energy is a product, and that energy goes away. Now, notice the second equation. Notice how it is a reactant. So in the reactant side, you have the energy is part of the reactant. But if you were to take that out and write it separately, like you see in the bottom one there, notice how it is a positive delta H. And the reason why it's a positive delta H is because that reaction absorbs that energy when it goes to the products. And so what we're thinking about here is when reactants turn into products, are they giving off energy, which is a negative delta H, or are they absorbing energy, which is a positive delta H? Now we're going to talk about endothermic and exothermic reactions. Negative delta H's are exothermic reactions because the heat is exiting. So that's where exothermic comes from. If you think about it, that's how I remember it. The heat is exiting, and so heat is released to the surroundings. And so if something has a negative delta H, that means it's losing heat, and the heat is exiting. It's exothermic. This is an energy diagram. And what it shows you the relative amount of enthalpy that a reactant has, so the energy that is within a certain reactants, and then it shows you the energy in product within a certain amount of products. And really what you're looking for is, does the energy drop or does the energy increase when you go from reactants to products? And in an exothermic reaction, when reactants turn to products, they lower their overall energy. The change in energy is a negative change in energy because heat is released in that situation. So if your products are lower than your reactants, that means they lost energy, which means the energy is released, and that is what an exothermic reaction looks like. Now, if we have a positive delta H, that's an endothermic reaction because energy is going into the system. And so heat is absorbed in an endothermic reaction. And so again, positive delta H means that the products are gaining energy when they go from reactants to products, and energy is going into the system. And so this is what the energy diagram looks like. So when we go from reactants to products, there's an increase in energy, and so the delta H is positive. Because it's absorbing that energy. So notice how the relative amount of energy that the products have is higher than the reactants. And that's it. So go ahead and watch those guided practice problem videos, and we will go over certain practice problems regarding that. Have a great day.